Hello everyone. Some of you know me, some of you don't. My name is Kuhlman. I'm one of the developers of a platform we're calling Eris. By a group of developers we're calling Project Douglas. It's an open source governance framework, Eris. So enough talking about money. You can all value money stuff, just sort of put that out of your brain, because none of this is about really the value in terms of financial value. We think there's a lot of value, but it's more in decision making. So Eris is a platform that we use a lot of different open source technologies, a lot of different distributed technologies. Ethereum is one of those technologies that we're using. It's a core piece of the entire platform that we're doing. But the real idea that we're trying to do is explore how you would actually do distributed decision making. And that a lot of people have their own sort of philosophical ideas about how they think decisions should be made. And we want to basically provide a platform that makes it easy to test out those ideas, to play with those ideas, and to see what works in kind of what contexts. I'm not sure if anyone was at the last Bitcoin Wednesday, but this will be, some of this is recycled from that, but I'll try to be brief on that stuff. And really this one will be, is meant to be more technical in nature and try to get down a little bit more into the nitty-gritty on what we're doing. But, first, actually we don't need to do that because we're not at the Bitcoin meetup. That was for, we're on Ethereum, but we don't hate anybody. Slide. All right, so when you think about making decisions, my background, sorry, I should have said this before, my background is in doing international development and legal reform, mostly in the Horn of Africa. So I spent the last 6 years or so working with advocacy people, with parliaments, and doing a lot of different legal reform work. So a lot of this is taken from my experiences in that. A lot of this is taken from experiences that other people in our group have had. My brother's a behavioral scientist, and he does a lot on, I forget exactly what you call it, but basically how your brain decides. He's done a lot of study on that, and that's what his PhD is in, whatever. Dennis, another of the lead developers, is deep into sort of the algorithms of all this as well. He's a quantum information guy. So we thought a lot about this, and when we think about sort of weighing centralized decision-making platforms, these are platforms that we know well, right? This is having a government where we elect people, and then they go basically take most of the decisions for us, right? Or in whatever the context is. In a company context, you have a CEO or a board of directors, and they're taking a lot of the decisions as well. Similarly, in nonprofits, the boards of nonprofits and foundations, the boards generally will take pretty much all of the big decisions. And so we kind of know how centralized decision-making works. And there are some real advantages to centralized decision-making. It's efficient, it can be fair, and it can be pretty predictable. Because centralized solutions, they have a lot of things that they have to manage. Then they kind of go, a lot of times, lowest common denominator. And one of the things that is somewhat advantageous, depending on one's perspective, about going with the lowest common denominator or not changing very often is that you have predictability, which if you need to do long-term planning, predictability is helpful. But there's some problems also, with centralized decision making. There's a bias towards the status quo. When somebody is when somebody is in a seat of power in a centralized system, it takes a lot to actually move the system in one direction or another direction. And so there is pretty much a bias towards kind of going the road that you are going. And we see this all the time in our own lives. Obviously, since we're all sort of maybe cryptocurrency or whatever, there's a single point of failure. And if somebody has to take a decision and there's only one person that can take the decision, and they're on a train and the train is in a tunnel, and they can't be gotten a hold of because there's no cellular connection or there's no internet, that decision won't get taken. Maybe that's okay, maybe that's not. Kind of depends on what you're talking about. And the last downside really is that centralized systems are easy to capture. This is why, in military terms, you have insurgents that don't provide a centralized surface for a military to attack. They are distributed because you can't capture them quite as easily. So those are some of the positives and negatives of centralized decision making. It's something that we know pretty well, and something that we have a lot of familiarity with. But we wanted to build Eris and try to play with some other ideas, some ideas of, well, what would a decentralized decision making scheme look like? Not only what would it look like, under what conditions is it better than a centralized decision-making platform or worse than a decentralized decision-making platform? What are the trade-offs of different ways of decentralizing? These were really the goals that we had going into Eris. So Eris, a blockchain-based decision-making platform. Now, the idea of Eris is to sort of follow the path that's kind of been well-trodden, somewhat in neuroscience, somewhat in kind of advocacy world, on how different nodes within the network work together to sort of collectively take a decision. I'm not so strong on the neuroscience side, but I'm a little bit better on the advocacy side. But generally the idea, the entry point into taking a decision is to have a discussion or a brainstorming session, or people call it different things. But really, it's to explore what is going on. And really, one of the big things is determining if there is a problem at all. And then, if there is a problem, what is that problem? And then if we can get that far, then we have to figure out, okay, how can we actually address this problem? So what Eris does to support sort of this step in the overall process is pretty straightforward. It's not terribly exciting. We have a basic forum functionality. Generally, the second phase of decision making really is a filtering process. And during this filtering process, really the nodes in the network generally have a little bit more pointed discussion that filters down and focuses the whole thing, and really tries to identify kind of what are the range of ideas as to what the problem actually is, and then what are the relative advantages and disadvantages of different ways of addressing that problem. And so we have Eris, we support this with basic up-down vote functionality, just like more or less a Reddit up-down system. And we have an embedded within the particular organization that is using any one Eris platform. We have an embedded reputation system. At this point, your reputation in any one Eris system won't necessarily transfer to any other Eris system. This is problem that will be kind of in another platform that we're going to build down the road. Then really the third step in taking a decision is formalizing what the decision actually is. And there's sort of two ideas of this, or two steps to this. One is bounding the problem, and therefore really saying what the nodes on the network think that the problem is, and then deciding on one or more precise solutions to what the problem might be. And we support this phase with an endorsement functionality. The endorsement functionality on an Eris platform is kind of like a petition system in sort of a government type setting. And the idea is that we've set up an aggregated reputation that you need in order to table a vote for the people within the organization. And that aggregated reputation, it could be a few nodes that have really high reputation, which is kind of similar in functionality to a few MPs can table a vote before Parliament, depending on the particular country that you're talking about. Or you need a lot of nodes that have a lower reputation in order to reach the aggregate reputation. And this is similar to a petition function that some countries have that would allow you to table a vote before Parliament. Now, then really the final step is voting. So at this point, the decision is formalized. The solution to what the problem is has been proposed and finalized with hopefully some level of precision, and you go to a vote. Now, out of the box, we support this with a weighted reputation-based voting mechanism. We are fairly close to also releasing a non-reputation voted weighted system. So it'll be sort of one node, one address, one vote. But those addresses would need to have a reputation above a certain threshold, which is basically our idea with that is that it takes a while to gain sufficient reputation and therefore sufficient citizenship within the particular organization. And then at that point, that node would have full voting privileges. There's a lot of ideas for how different voting things could actually work. And the way that voting works, I'll get to the details in a little bit more in a few minutes, but the idea is that there's really two contracts that control how voting works. So really anybody can swap out those contracts and they would have a completely different voting methodology that would be their own, and they could use the rest of the system however they wanted. Yeah.
Is it a yes/no vote or?
It's a yes/no vote. Yep. It's not at this point. It's not a qualitative vote, but again, it's just two contracts, so someone could change that however really they wanted, and you can have all kinds of different voting. You could have like a tag-based multilateral voting system. You could have a lot of first past the post type of voting methodologies. Really, the idea is to have the base as a platform, and then anyone can fork it and deploy it, and just switch out whatever components they want to test, and then give it a test and see where they're at and deploy it, whatever they want to do. So that's kind of the idea. To try to give a brief overview on how Eris works. More or less, out of the box, Eris is a Reddit, but there's no servers involved whatsoever. In a traditional, but it runs in your browser. And how we've structured it is that traditionally, in a web application, if you're going to Google or you're going to Gmail or you're going to wherever in your browser, you'll have at the bottom of the stack, you'll have some databases, usually a cluster of databases. And then you'll have sort of a model and a view and a controller if anyone's software developer is in here. And then all of that together will sit on a cluster of servers that belong to or are leased by or are operated by the company that is providing the service that you are using at that time. And then at the very end, you'll have sitting on your computer a browser, and then you'll get some HTML files and some JavaScript files and some CSS files, and your browser will put that together and you'll have a pretty web application that you'll be looking at. Now you control, the piece of that you actually control is, whatever. It's a very small bit of a pretty substantial stack. So that's kind of traditionally how a web application would work. The way that Eris works is that we have, you still view it in a browser as you would anything. And then we have what we're calling a desk server or a decentralized server that runs either on a user's personal computer or a personal cloud droplet. It's not made to run on servers. It serves HTML and JavaScript and CSS, but it's not meant to run in a cluster of servers. It's meant to run on your either on your computer or on a personal cloud droplet. Then underneath that, we have another component that's called C3D. What C3D does is it's contract-controlled content dissemination. And what that does is it sort of puts together everything. And I'll talk about sort of the pieces in a minute. But C3D puts together all of the pieces that are at the base of the stack. And then it gives all of those pieces in a cohesive way so that the desk server can send it up to the browser. Then at the very bottom of the stack, what C3D talks to are sort of three major components. It talks to the torrent, the BitTorrent network via a BitTorrent client, and all the files that we use for defining the data models, for the UI, for all the content are all stored in file blobs and shuffled around the users of any one particular application using the BitTorrent network. Then it also talks to two different types of Ethereum contracts. It talks to contracts which are database contracts on the Ethereum network, and then it talks to bylaw contracts on the Ethereum layer. And the bylaw contracts are more or less the API for the whole system, and then the databases are basically read-only. What it really is it's meant to be a platform. It's meant to be personalized. So if anyone has seen our screenshots of it, Eris is very ugly out of the box. And that's on purpose. We haven't made it pretty, and we have no intention to make it pretty. Because really the idea is, that we're going for anyway, is to have a real baseline, and anyone can just fork it, add their pretty stylings for their organization that they want, and then they will deploy their own application that's based off of the Eris platform, if they want, onto Ethereum main network or any. There's no reason to think it wouldn't work on really any fork of Ethereum that's relatively recent. So, I mean, I take no stand on that issue, but in any event, that's the idea that we're going for. To deploy a particular application or the whole system of contracts it's not cheap. Right now, it takes over 250,000 gas. So gas Ether is in the Ethereum system. For those that don't know, Ether is sort of what's the best way to put it? Like the store of value. I hate using that term, but what's the difference between ether and gas?
Just forget about gas. It's like the step you pay for each instruction of a contract to be executed.
Okay. Yeah. Exactly. So gas is what you really pay, and ether is sort of a convenient wrapper for gas. Okay. And so it takes 250,000 gas to deploy an Eris system. That's a lot. Most contracts that I've seen take less than around 1,000 maybe, but to deploy a whole system takes 250,000 gas. Just to have the Eris, an Eris application, right now out of the box, it's 30 contracts that are created during the deploy cycle, and then there's over 50 transactions that happen to set the whole thing up, to set the permissions, do different things. That's a lot of work. So we made a package manager that will do all of that for us or for anybody else. So on our GitHub page, if you're very interested in developing systems of contracts, maybe take a look at the EPM Ethereum Package Manager, which will basically automate all of this for you. Okay, now to try to dig into the architecture just a little bit. We have two different, as I said before, we have two different types of contracts that sit on the Ethereum network. The first are what we call bylaws, or they're kind of the API for the whole system. And they live on really whatever blockchain the user is using. And what they do is they explicitly control access to the databases. The databases don't respond to a transaction that is not sent to them from a bylaw. And we've built this. We built them particularly in that way. So it's fairly open what you could do to a database, but the database won't respond to you unless you are an approved bylaw. At the core of the whole system is one contract we call Doug, which is kind of the kernel contract, Kernel, for any Unix or POSIX people. That's the core of the whole thing. That contract is what says you are a bylaw or you are not a bylaw. And so if it is a bylaw, then the databases will respond as long as other conditions that are programmed into them are met. The second type of contract that we have are contracts which are databases. So really we have two different types of database contracts. We have pre-configured databases, and these are do really sort of core things to the platform. So we have a couple of different reputation databases, a citizenship database. Doug itself is a core database. And then what we have are factory spawned databases. So we've built for this factories. And these factories, when they receive a transaction from an approved user, they spin off another contract which gets linked up into a whole tree of different contracts. So there, for example, if you're thinking of like a typical Reddit type of an application, at the very top you will have sort of subreddits, right? And we're calling those topics. And so those topics, each of those is a contract. It's a database contract. It has certain access privileges, and it keeps certain information. And then it is linked to one level down in the tree. It's linked to different threads, which are like individual Reddit threads. And each of those threads is a contract. It's a database contract, and it has different access privileges, and it contains different information. And then one level down are posts, and each of those is a contract, and they contain different information and whatnot. So the whole thing makes a tree, and when a contract gets spun off from the factory, it links into that tree in whatever way it is supposed to. So all the database contracts, they hold their information in a spec so that the C3D system can read them. At the top, you have high-level slots, which are really reserved for kind of high-level information about that contract, such as the data model, the owner of the contract, the parent of the contract, the UI files, and other things. And then underneath that, you have usually blocks of linked lists that store additional pieces of information. This is what the interface looks like. Don't worry about the nice little text there. This is from our test spec that we use. But just to give everybody an overview here of what's happening, each of these things on the breadcrumb section are referring to individual Ethereum contracts. So in this one, we're sitting basically at a topic level right now. And then these are different topics, and each of these links is to an Ethereum contract. Over here you have the actions that you can do. So for example, you can go to My DAO here. You can, up here you can see what the current community is. This is the address of the current Doug. And you can subscribe to this community so the torrents will automatically download in the background. You can switch, you can request to join a different community, or in one click you can have your own Eris. C3D is sort of the connective tissue of the whole system. More or less what it does is it reads what's on the chain and it does things off chain. The main thing that it does right now is it throws file blobs or magnet links into a torrent client, but we want to expand that so it can do different things, such as hop into a database and read a Git repo, do different things that will be coming, but right now it will do that. It'll also read all of the database contracts and formulate that whole UI that you saw from everything, and it'll send that to the desk server. Then the desk server is the server on the system. It's really quite dumb. It just serves the HTML, JavaScript, and CSS. If you want to know more about this, the demo we did with Eris is down here. There's all our contact information. I'm sorry, maybe that went a bit long, but now questions?
Can you give me an example of a problem that is suitable for Eris? Like the financial decision, where the decentralized feature makes sense.
Yeah.
What are you making this for?
We're making this for an experiment. Where the decentralized decision making makes sense, I'm agnostic as to, if I'm honest. I'm doing this because it's fun and it's interesting to me. And I think we're very, very early in the process. We know, for example, that at least one quite small political party in the US is using this to develop their political platform. We're using it to develop our own platform, and that's a few ways I know it's being used now. And we have been in very early discussions with a trade association as far as using it to basically as the backbone of their foundation. So that's the early use cases that I know right now, at least.
I know of liquid feedback, yeah. So liquid feedback is kind of a particular implementation. I mean, it's a philosophical implementation, more or less, I think, right? Or liquid democracy, right? Are we talking the same thing? Yeah, yeah. So you could run a liquid system on Eris without a problem. I mean, it's really just a baseline framework for decision making without servers. Yeah, yeah. I mean, that's kind of how we view it. So we want to develop. So liquid mostly is a lot of the liquidity in liquid, from what I understand, really comes from the proxy system that is used. And we don't explicitly have proxies, but anyone could do them. We don't offer them out of the box. We've talked about it, and it's on our work plan to have it out of the box available if people want to use. But it would just be another contract to write, and anyone could use the rest of the framework to do that.
Maybe it's an issue that's been discussed openly with. I was just wondering. So you said it will run on any fork of Ethereum. Mm-hmm. Do you envision a future where people will choose a fork of Ethereum to deploy Eris on, depending on the level of security they want?
Yeah.
So that would be one of the use cases of having multiple Ethereum.
Yeah, for example, like in our tests, like I was saying, we use it to talk about what we're going to do and have small little votes among the few of us. We run our own testnet to do that. Okay. And if we were to have a small cron job, it just backs up the blockchain. If we were to be attacked, no problem. I just roll back the blockchain to the last bit. And if we lost something, then we lost something. I mean, it's not for us. It's not mission critical. If it were to be mission critical and you needed really high security, then the advantage would be to go to a more public chain that had more security. Mm-hmm. But I mean, I sort of view all of this as a continuum, from completely private chains that are run within any VPN of a corporation that have nothing to do and don't really care what the value of Ether is compared to a Bitcoin, and then completely public implementations where you need a lot of security and you don't have sort of the VPN outside ring of security, so you would need all of the security that comes with having a huge mining pool and a fully public blockchain. And I think there's a continuum of realistic possibilities between those two extremes. I mean, it uses just the virtual machine and blockchain protocol, so there's no reason to think that it wouldn't run on any real recent fork. I mean, I'm agnostic as to that. So.
But that would be feasible because you store everything in a blockchain, which is really expensive. It's also like what we call content, so coins, etc. Would it be feasible to these high bandwidth or high storage things? You store them in a cheap blockchain, and then things like reputation or stake, the amount of votes you have, you would store in a more secure blockchain.
Yeah, we've been talking about that. The challenge, if they were both Ethereum compatible, it would be easier. So if both the blockchains that you were looking at were Ethereum protocol compatible, it would be easier. But still without having oracles or trusted oracles, it's really hard to do cross-chain stuff. But if you build oracles into your system that would certify what things are between the chains, then you could do it. Or if you had clients that could sort of dynamically read both chains, you could do that as well. It would need to be a lot more developed before running one application on two different chains would be feasible. It will take a while. It would have to have some client-side development, I think. I don't know. Nick might know more about that than I do.
Why did you choose to
implement partially on a forensic network, rest on the blockchain?
Yeah, that's a good question. So storing all the files on the blockchain would be really quite expensive. And so we all we do is we store magnet link pointers on the blockchain. It's much cheaper, and then we can store all the files on the torrent layer. It was easy to do that way. Other people have more advanced solutions. Filecoin, Datacoin, different people are working on different solutions now.
So Casey, maybe I wonder, would it be good for a situation where you want to make sure that the actors who are busy making a decision, that they conduct the decision-making process in a transparent way, and that they follow a predetermined set of rules in reaching that decision?
Yep, that's exactly what happens. Yeah. I mean, unless the file blobs or the discussion, unless they've been encrypted, anyone that uses the DAO will have access to the whole thing, because all the important pieces are all the history of everything is kept on the blockchain. So if you have access to that blockchain, you would have access to all that stuff, and you would have access to all the file pointers. If they were encrypted, you couldn't see what they were about, but if they weren't encrypted, which would depend on the user and how they deploy it. C3D does encryption. It does GPG encryption right now, and it'll do electrical curve for files.
So could you say that it's a verifiably fair process and a verifiably fair
I don't know what's
decision?
fair. I mean, fair is too subjective.
In the sense that it would be predetermined, that it would not be deviated from what was the way it was set up in the first place.
Well, it could be deviated because the whole system is meant to be dynamic. You can change the rules. If you can get enough consensus to change the rules, you can change the rules. But it would have to be sufficient consensus that the rules were changing in order to change the rules. Other than that, the system would not respond if the rules were not, if whatever check was in there was not being met, then the system simply won't respond.
And I was just wondering, you mentioned that wallets have a certain weight, like a citizenship standard. Do votes have weights as well?
Out of the box, yeah. So out of the box, it's reputation weighted for voting. Wait, no, actually we changed that. Sorry, we changed that. Out of the box, it's one node, one vote now. But you could do reputation weighted voting. Yes, sorry. We had a discussion just before I went on holiday, and I'm just trying to remember everything. Yeah, that's where we are now. Sorry.
Casey, thank you very much.
Thank you.